So today this radio is going to jump the queue. We've got a audio line in front of this. I've been busy on business radio, so I can't show you those, as the frequencies are confidential. You won't be interested anyway. But this is coming from another electronics engineer, Andy, at Stockport, who I've known and dealt with for donkey's years. Specialist in NSM jukebox systems, and so he overhauled one of our jukebox carriages, and there you go. So Harvard 420M, they don't get much better than a 420M. I think they're better than the well, we found they are better than the Rotel 230. We discovered they've got the better receive. Actually, I won't take any more screws out, just take a couple out, and we will go through this set. Now, he is a very well qualified and experienced electronics engineer, but his specialist subject isn't two-way radio, and he has asked me to check this over because he has been through it. Let's put the power supply on. We'll go straight to 13.8 volts, limited to 1.6 amps, and straight away we can hear the set receiving. I'll go into picture in picture, and it's transmitting too. Now, of course, I'm going to have to untune it to tune it. So we're going to... That's my electricity statement. I've stopped paying monthly. I pay when the bill comes. I'm not paying what they want me to pay, which is double what I'm using. I really don't get that. Why would they want me to pay double than what I'm using? You know, if I use X amount a month, why do they want Y amount? I think it's not like he's earning huge interest. Right. So, Andy's Harvard 420M. I think it's the only Harvard with the Cybernet chassis in it. Oh, having said that, the 402 MPA and the base stations are Cybernet chassis, but it's the 002F economy chassis rather than the 134 chassis used in those. But nevertheless, they're good performers. I think Harvard were let down by the Good Buddy. Is it H403 Good Buddy? Oh, what a dreadful set, and it's so unreliable. Lots of features, but just so unreliable and so badly made. And that same chassis appears in the Harvard H404 and the Alba CBM5. So we're going to go through this and see exactly what he's got. So we've already seen in transmit that it was more than 3 watts. He's got 3.5 on our rather selective test set here. Out of interest, see how he's balanced these channels. Channel 40, 3.2, channel 1, 3.5. So I'd like it balanced better than that. So deviation, remember we're looking for 2.2 to an absolute maximum of 2.5. Wow, it's 1.8, so that can come up. Frequency, I've only had the test set on 10 minutes, so we can take this with a pinch of salt. That's fine. It's not our frequency, but we can pull it up a bit if we need to when the thing's warmed up. What I'll do, I'll put his on frequency and then I'll look at it in about 4 hours time. And then on receive, let's go over to the synod meter. Let's get magic 12 on that. And then we'll look at the attenuator. 1, that's 4, and it's in between 4.2, 4.4, so it's 4.3. So that's excellent. 0.43 microvolts for 12 dB synod. Out of interest, let's do 10 dB. That's 0.35 for 10 dB, and we'll see if it will do 20. Not all sets will. It's 1.3. Of course, this changes when you alter the tone. Hang on, RF gain wasn't at full. Yes, I'm going to have tone at full. Just go through those again. So for 20, it's 1.4. For 12, it's 0.49, and for 10, 0.37. Right. We'll open it up. You never know, I might get him an extra 50 yards range. I'm sure his handle is Big Mac. You get the bigger speaker on these sets, like you get on the Binatone 5-star and the 76900 Midland base station. So I can't see anything dodgy on the face of it. We've got the extra receive circuit, but not the extra receive circuit you get in the base stations. So we'll check the VCO. So we'll pop the radio on channel 40. I'll take picture in picture off and hopefully remember to put it back on. Borrow Mr. Chippy's green crocodile clip lead, which has got trapped around something or other. There we go. Use that wire there for the earth. Change glasses. $4 it's supposed to be on receive, and that's 4 volts. I'm not altering it for that because there's going to be a tolerance between meters, and on transmit it's 4.2, so I will adjust that one. Don't really want it to be different from 4.1, but you know, I'm going to waggle that round actually. It was a bit too easy to move. Now we go to channel 1 on transmit. It's between the 1.8 and 2.5, and on receive it's between the 1.9 and 2.5. So it didn't need adjusting, but I'm picking it. I'm really nitpicking there. I mean, I've got the £16.99 meter. He might have got the £400 meter. Like it's going to make any difference if you do these kind of things. Right. I can't see any capacitors that are tired, because they're usually going to be starting to shrink back and look like they've been circumcised. So that's fine. There's nothing you've got to automatically change in one of these, not like the Unidens. And it's a Uniden I should have been doing, but Mr. Chippy's otherwise occupied. It needs a full recap. The customer's asked for that, and so it really needs to go across to Mr. Chippy. So I thought the best thing to do is to do this rather than nothing, or rather than one of our own sets, and then at least it does go back to the customer, but it has pushed in front of the audio line because of the audio line wanting more doing than I can fit in, and what Mr. Chippy can at the moment. So we've done that, so we'll run through the transmit, taking the set back to channel 20. Let's just check it on PA, we never did that. Testing 1 2, testing 1 2 1 2. That works absolutely fine, and it works on the volume control. You might think that's obvious, but not all sets do. So put picture in picture back on. I'm going to transmit. So the idea is maximum on all this. I don't think any of those were out. And then with the over expensive trimming kit, we want maximum on all these three. Temporarily. Do not ever leave these on maximum. You will kill the set. Legality aside, because obviously you'll be doing more than you're allowed to do, but legality aside, you're going to end up with harmonics and you will kill the set. We've got many proofs of that. Now this set is not doing 4 watts. Just check none of these have been messed with. Because this happens as well. Let's run through those again. So we're in a situation where the radio is doing 3.8 watts, and the manufacturer says that these radios will do at least 3.8 watts. We're at that situation where it's at that end. So to align it, we're supposed to be taking this forwards to get to 4.4 watts, but we can't do 4.4 watts. And you know what I'm tempted to do temporarily, and I'm going to up the voltage slightly. It's not my set, but I think just so we get align it right, we'll take the voltage up a little bit higher. I'm going to take it to 14.4 volts. Let's see if I can remember how to adjust the power supply. So we're now at 14.4 volts. And the radio is now doing 4.4 watts. So I'm going to adjust clockwise till it just starts to move, which is there, and adjust anti-clockwise till we get to it just starting to move, which is there. Now that's 4.05 watts. So we've just hit the 4. I'm going back to 13.8. Just like that. So we should be balanced. So let's see where we are. So with 3.6 watts on channel 20. .6 watts on channel 40, 3.7 watts on channel 1. So I have balanced it a little bit better. So if I was putting this in our Nissan Leaf, which charges at 14.4 volts, this would be doing a full 4 watts. So when this cools down, it's probably going to be about 3.8. So on the meter, when we key up, we should get this banging across the 4. And you know what, he's got it about there. I'm just going to bring it down a fraction. We're dead on the 4 there. Low power should be 0.4 of a watt. It's got 300 milliwatts. We'll just give that the slightest adjustment. A little bit of service on, I think, on that. He's probably already done that. .400 milliwatts. Go back to normal power. And now we'll see where we are. I'm not showing you all the right meters, am I? So now we'll go over to deviation. So here's your transmit on low power, 400 milliwatts. Here's your transmit on full power, about 3.8. Now it's cooled down a little bit. And now we'll go over to deviation. I'll just have to reset the machine because I was on VHF high band before. Wallow. There we go. 1, 2. Wallow. So I want this to be in the central position, which it more or less is, and then we'll adjust this with the oscillator till we get 2.2. See where that is. Wallow. It's a little bit high. Let's try it there. Whoa, that's better. So we're going to call that 3.8 watts. I'm going to say that's 2.2 to 2.5, which is where it should be. Done that. Do the frequency, and I will check it behind the scenes later, just to make sure. Pull those away. Frequency. Just put the camera on there. See what it is now. It is coming up, but I will just bring it in. Right, now we'll concentrate on the receiver. So first of all, that pesky detector, we'll put an S9 equivalent signal of 100 microvolts on the test set, and we will select the oscilloscope and turn the bench light off, so we can turn enough volume so we get a decent trace, and adjust the coil there. You got that spot on. I don't think we're going to get anything better out of this receiver. It's excellent. You just never know. So on the sine meter, (4 dB). Start here. Oh, got a tiny bit there. Bigger signal for the next one. bigger still signal. Right, we'll go back to a smaller signal. Much smaller signal. Let's read off the new figures. So now we've got for 12 dB, I'll put the attenuator on so you can see that. So we've got 4.246, 4.7. So it was 0.49. So we've got that's a 0.47. So neither here nor there. 10 dB, 0.36. So it was 0.37. And for 20 dB, might have improved that. On the other hand, I might not. Yeah. Well, this time I'm reading 1.45. Yeah, so that's it. So you've got the receiver spot on. Just a bit of that balancing on the transmitter. And I just wanted to set the deviation a bit better. So now on the signal generator at 100 microvolts, we should have S9. He's bang on S9. So next, do the squelch. If it wasn't, it's the preset just there. The squelch, which is the preset just there, I'm going to set to full. And take off picture in picture. So what I want to happen is it's open at 100 microvolts, S9 equivalent. So it's at 3, 10, 30. It's coming in too early. If I can find the preset. Hello preset, where are you? So that's increased it a bit. So 100 microvolts is coming in. So now we'll check it the other side, and that means we're going to turn the squelch all the way down, put the signal generator on standby, and we'll advance the squelch on the edge of the threshold. There we are. Now we'll switch the signal generator back on and see when it comes in. It's coming in at 0.408 microvolts. It's leaving at 0.4 microvolts. It's nice and sensitive. Not the best squelch in the world on these sets, but they are adequate. So that's it. I'm going to put the lid on for now. This is a bit short. Just put a screw on in it so it doesn't fall apart. Now he's got a screw missing out of this mic plug. We've got those for 25p. Knights sell them. I'll get them therefore from them retail. I'm not going to fit one. He's trade customer, so he can sort his mic out himself. Just want to tighten up that screw. No, they're all tight. Okay, so just missing the tiny, teeny weeny screw. Let's just see what it sounds like on the handheld at close quarters. Testing 1 2, testing 1 2. Roger. Okay. Switch the signal generator off. Put the aerial in. Take the extension speaker out. One and a Roger. Yeah, I can't see that meter needle. That meter's got a tendency to stick. So again, with him being a trade customer, I'll leave that up to him. So, not heard anybody on it really, apart from somebody on 37. We'll do an on-the-air test later on. And we won't put it on a screwdriver, we'll put it on a bench cookie. So there we are. So that's a Harvard 420N from trade customer Andy. And yes, he's got that pretty close when I look at that. You know, the receiver's the hard bit, isn't it? And he's got, I couldn't adjust that any better. So yeah, just the deviation probably could have been a bit higher. But you'll be able to see what my readings are to what his readings are and take that into consideration in the future. So thanks for Andy for sending that in, and thanks to the viewers for watching, and we'll have an on-the-air test later on with this set.